Hey, listeners, welcome back to Sustainability Street, our podcast on the intersection of commercial real estate and the world we live in. I'm your host, Therese Fitzgerald. When the term smart building was coined back in the 80s, no one could have imagined just how intelligent buildings have become. And with fast moving artificial intelligence, the possibilities are endless. For this episode, I'm talking about intelligent buildings and energy with Jennifer Nuckles, chairperson and CEO of R0, a company that uses real-time occupancy data to automatically reduce owners' HVAC costs and lower their carbon footprints. The company's sensor technology is also used to automate indoor air quality management. At a time when owners are hyper-focused on NOI, Nuckles told me, advances in building technology have enabled energy to transition from a fixed, unavoidable expense to a controllable material driver of operating expense and valuation. This was a really interesting conversation for me, and I know you will enjoy it too. Hi, Jennifer. It's great to have you on the podcast.
Hi, thanks for having me.
Before we start talking about intelligent buildings and AI in buildings, let's talk about your sustainability journey and the journey that led you to your current role.
So, I always say to people there are three things that I care about in life, and it is education, the earth, and technology. And I feel really fortunate to be able to work at the intersection of all three. So, a lifetime ago, I spent more than a decade at the Clorox Company. The Clorox Company is a large multinational company. Everyone is familiar with Clorox products. We all have them in our kitchen and our bathrooms. We use them when people get sick. It is a large petrochemical company. And I launched the first line of natural cleaners at Clorox. It's the first brand in 80 years for an over 100-year-old company. It was a line of cleaners called Greenworks, and we got to 100 million in sales in the first quarter. And this was quite the uphill battle to tell my executive team that I believed there was a market for people who cared about not only being healthy and clean, but also not having chemical runoff into the waters that we all drink and our animals all drink and that are surrounding us. And there is indeed a market for it. And there's a number of people, individuals in the world who care about sustainability. And so that was kind of my first foray. And then I worked in a variety of technology companies, officers at large, publicly traded companies. And I was always hungering to think about what are the other things that are really impacting the world we live in. When I took the seat at R0 about 3.5 years ago, the company had a super rich data set about all of the buildings that all of us are occupying. And I started looking at that data set, and it was pretty astronomical to uncover the largest cost in buildings that also have a disastrous effect on the earth that we inhabit, which is energy. And the largest cost of a building is HVAC, heating, ventilation, air conditioning. It's about 50% of the cost of a building and 50% of the energy cost of a building. And much of that can be avoided. There's a lot that comes with that in terms of OpEx reduction, but more importantly, emissions, all the ESG reporting that companies go through. And so I feel super fortunate that I'm able to use technology to address an operating cost issue that also has a better impact on the world.
Everyone is concerned about energy today, so you're in an exciting place right now. So let's talk about smart buildings. We've been talking about smart buildings for decades now, but buildings have gotten really smart lately. What's changed that allows buildings to function more like intelligent, self-optimizing assets today?
Yeah, it's a really good question. So smart buildings have existed, the narrative, 15, 20 years. And what's really different is not one thing, but it's a composition of many different things. So what's changed recently is that several technical and economic inflection points have converged. And what I mean by that is that for the first time, buildings can meet all of the requirements of an intelligent system. So first of all, there's this idea of perception. we can understand now what's happening in the real time, minute by minute in a building, as well as an environmental setting. That didn't exist even 5, 10 years ago. Context, integrated data across systems, that didn't integrate as well. Previously, buildings operated as static machines, one by one, not a portfolio view. Decisioning is now very much more advanced than it was even 5 years ago. Adaptive models that are optimizing towards objectives. And I think the biggest thing is that this combination just simply didn't exist before. And we also now have moved from like sparse proxy data into actual data that is real-time truth. All of these things are coming together at a time where capital is no longer cheap. And the cost of capital, 5 years ago, anyone could get capital. Now buildings are operating at this idea of we need to understand what's happening, but we also need to look at it as an asset, not just an expected cost. And so the way that historically buildings have run has drastically changed real time.
And would you attribute a lot of that to AI?
I think some of it, I think a lot of it, but I think, you know, right now the shift into focus on smart buildings isn't philosophical. I think it's mathematical. And what I mean by that is energy has moved from a fixed, unavoidable expense to a controllable material driver of operating expense and valuation. Because if you decrease the operating expense of a building, you increase the net operating income and you drive up your asset value.
Hmm.
So I think the fact that the cost of capital is now expensive and there's a big focus on efficiency are two things. But then I think AI in real estate is real. There was a lot of hype around it, as you mentioned. What's different now is that AI has moved from advisory intelligence into actual operational control that's tied to real world outcomes, real world cost reductions. And, earlier waves of smart buildings were insights, and now it's really about executing decisions inside the assets. And generic models are no longer the norm. Now we have asset specific, time specific learnings.
Mm. Agentic AI is now in buildings.
Yeah, I think that's super important. You're seeing that even the idea of AI originally was large language models to run queries, and now to actually make the decisions and do the actions, which has really only changed in the past 4 or 5 months.
Wow, that's pretty recent.
Yeah.
And all this is happening at a time when, as you said, there's a big focus on improving NOI because capital is more expensive and people are not buying as much.
This is the core driver, right? The math is really simple. If you have energy savings, it's a dollar for dollar OpEx reduction. Your OpEx reduction is the corresponding NOI increase. Your NOI increase amplifies your asset value. Like if you take a $500,000 annual energy expense saving at a 5% cap rate, you have a $10 million increase in your asset value.
Okay, so let's talk at the building level. How are we moving from static building operations with fixed schedules and set points to truly real-time responsive properties?
So we are effectively replacing a decades old system, design time assumptions, fixed schedules with a live, continually optimizing control system. And what's actually happening under the hood is number one, the control model is being inverted. The old model was really static. So it was designed for peak load. The systems were run to that assumption. Fixed schedules were applied, 6 a.m. to 8 p.m. And then there was occasionally rebalancing. The new model is real time. So you sense actual demand continuously. I like to think of this as like you put the energy where the people are. You predict the near term, real time conditions, and then you adjust the system's output dynamically. So we move from this assumptions and then, operate to now observe and respond.
I'm sure that's very helpful in office today when schedules are more flexible and there may be some extended vacancies.
Yeah, and it's not only at the to your point, it's not just at the like portfolio planning level. It can be predictive. It can be In an office building, for example, when you look at a Monday through Friday schedule and you're looking at one conference room and it's being ventilated for capacity, maximum capacity of 30 people, but there's two people in that room. We now have the ability to dynamically change, reduce the energy just for those two people, not as if we're assuming the building was fully occupied.
Let's talk about this in terms of sustainability. You mentioned in our earlier call how sustainability has become more of a core financial strategy for building owners. What's driving that?
Yeah, I think when sustainability stopped being externally motivated and really became a line item with direct P&L and valuation consequences, people started paying attention. So once that linkage was explicit and measurable, it wasn't really just a siloed ESG target. It became more of an asset strategy. So number one, carbon is now financially priced, and this is explicitly and implicitly. So think about regulatory frameworks like in New York City, for example. New York City Local Law 97 imposes direct penalties that are tied to emissions. And there's many other cities that are following, Boston, Philadelphia. So carbon reporting is becoming standardized, and in many cases, it's audible. And even when there's not a formal carbon tax, there is this implicit cost of non-compliance, whether it's fines and retrofit costs, stranded assets. So I always think of this as like emissions are no longer abstract. They're really predictable cash flows now. The second thing I think is that energy and carbon and cost have all collapsed into one variable. So, the largest driver of emissions is energy consumption. And it's being thought of that way instead of kind of being broken apart. So sustainability initiatives are now indistinguishable from margin expansion initiatives. And the Office of the CFO is really paying attention. I think another, probably the third biggest impact is the capital markets are underwriting operational efficiency. So, institutional investors, for example, have changed how they value assets. They look at the EUI, which is the energy intensity of an asset. They look at forward compliance with emissions regulations. They look at the efficiency of a building. And inefficient buildings are seen as high risk and future capex burdens. How much are you going to have to put into a building? It's going to cost a lot, right? You and I were talking earlier just about the cost of renovating your house. Like put that into a commercial real estate context. It's a significant burden for an investor. So, sustainability performance then starts impacting the exit rates and the buyer demand and the public valuation. So sustainability has moved from this like do good into like, hey, let's save money. Let's put a price tag on this. And if you're doing good at the same time, it's a win-win for everyone.
Right. And tracking that, I'm sure, is very important too. So you can show those numbers.
Yeah, the ROI is immediate, right? So previously, sustainability initiatives were like long payback periods, uncertain savings, difficult to measure. Now you have high frequency data, which is feeding to platforms, third-party platforms for validation. You have building specific baselines and continuous measurement and validation. And then you have really software-driven optimization. So the ROI is no longer kind of an estimate or uncertain, like it's provable immediately.
Speaking of data, there's a lot of talk today about the data layer of a building and how you need to get your data layer right. What does the data layer of a modern building look like today? Or what should it look like?
It's funny when people talk about data. I think in the past, the data layer was like a loose collection of data points that was trapped inside a BMS, a building management system. Today, it's like a normalized time-based series of record that sits above and connects every operational subsystem. So you have, at a minimum, you have your physical system telemetry. So like the BMS and the equipment, your AHU, air handling unit status, your VAV airflows, your static pressure, your fan speeds. So really physical as to what the building's doing. You also have your demand signals, which is your occupancy and your usage, which can be at the room and zone level, which can be motion detected, dwell time, utilization patterns, bookings versus actual usage. If you think about conference rooms, a big frustration in commercial real estate is overbooking of conference rooms and then no one goes inside them.
Mm-hmm.
You have your environmental context, which would be indoor, like your temperature, humidity. Outdoor would be the weather, the cost of the energy and the financial data. So all of this information, which was provided to facilities and infrastructure managers before, it was kind of just data overload. But now these data streams are in one system. They're talking to each other, they're normalized, they're time aligned, they're contextualized. So you can finally answer questions, like what was the airflow and occupancy in this zone at 10:15? Was it optimal? Before it was just you were kind of flying blind, even though you had all of this data, you didn't know what to do with it.
I want to return to something we said earlier about the focus on optimizing current assets rather than building new. Can you talk more about that?
There's so many more old buildings in the US than there are new, right? And so this is really structural. I don't think it's that owners are like preferring optimization over development. I think they're being forced into it. We talked earlier about the price of the capital markets, risk asymmetry. But I think what they've realized is improving existing assets is the highest probability path to their NOI growth. And existing assets are kind of under optimized by default. Most of the buildings are operating on assumptions, on fixed schedules. They haven't been recommissioned or optimized. They were kind of like set and forget it when they were set. And they have really conservative assumptions. And so what's changing is that there's latent NOI sitting inside the asset. And NOI growth from operations is cleaner than from revenue. It's a lot
Mm-hmm.
easier to save a dollar than it is to raise a dollar. Owners have like two primary levers, right? They can increase their top line rent, um, which is super hard. We know that it's market dependent. The market's changed a lot in the past 5 years. It's really competitive. It's slow moving. Or they can improve their bottom line. And this is owner controlled. I like to think of this as like if you walk into a room and there's dollar bills lying on the ground, do you want to lean over and scoop some of those up? Like we do,
Mm-hmm.
right? So let's not leave inefficient costs on the table.
There has been a lot more emphasis on adaptive reuse.
Yeah, and I think there's like a lot of small changes that disproportionately become really valuable. And so even a modest optimization, adaptive can generate millions of dollars in asset value and without construction, without leasing, without entitlement risk.
Mm-hmm.
We talked in our pre-call about how technology is allowing owners to meet compliance goals without taking on major capital expenditures. Tell us more about that.
Yeah, I think they're operating their way into compliance. So using technology like software, data control to unlock the reductions inside their existing systems versus spending their way out of the problem. So we talked about local law 97 in New York City, for example. So these are resulting in tighter emissions limits. Most buildings are operating inefficiently before they're obsolete, before they're mechanically obsolete. So the owners now are reducing runtime, reducing airflow, reducing outside air. Because those are within their control. And this means meaningful emissions reduction without replacing their HVAC and without having to result in CapEx expenditures in a shorter time period. Continuous commissioning using like software, not consultants, is a big theme now. The traditional path was hire an engineering firm, recommission the building every 2 years. Now you can have continuous monitoring and automated tuning. And so it's just much more real time. And I think the tools that are available to owners and operators have just made this astronomically possible.
And AI is going to get better and better.
Yeah, faster, right? You can make faster decisions, which is an efficiency lever in itself, and save costs. Leverage the existing infrastructure, right? Most buildings already have the BMS with controllable points. They already have sensors, even if it's incomplete. They have network connectivity. So the modern approach is to integrate with the BACnet, targeted sensors where they're needed, overlay the intelligence on top of the existing systems.
Something else we talked about in our pre-call that really interested me was how office and industrial used to operate very differently, but now owners are spreading the costs or spreading the data across asset types.
I love it. Historically, office and industrial were classified as different asset types, but also run using different operating systems. So the office was optimized for comfort and schedules, industrial for output and uptime. And what's changed is now we're both being forced into the same optimization framework, which is maximize your output per unit of space. And I think it's being driven by energy intensity is material in both asset classes. We certainly see the grid being constrained now because of AI, and it's expensive. And so as the price of energy increases in cities, it's impacting surrounding areas as well. You know, previously office energy was meaningful, but it wasn't really aggressively managed. And industrial was embedded in operations and it was accepted as fixed. Now the energy costs are rising across all asset classes. And
Mm-hmm.
industrial, which is hugely energy expensive, is becoming even more so. And office NOI is under an incredible pressure. So both sensors are now treating energy as a first order economic variable to be addressed.
What do you see as the next frontier, or what do you hope to see?
Oh my gosh, I
And
think that the world that we are living in is so exciting. And it's like, I mean, if you think about the age of the modern computer or the age of the iPhone, like we are now in another maximal pivot point. And I think what the world will look like in 6 months is drastically different than it is today. But the idea that AI is conceptual is antiquated. Like now you can use real-time signals in the physical world, and the physical world is kind of the next frontier of AI. And so I think it's a super exciting time to be looking at these asset classes in real estate.
I always ask my guests where my listeners can get more information on the topic. Is there anything that you're reading or listening to, or organizations that you're a part of that would be helpful to them?
Yeah, so I try to stay focused less on AI tools and more on how AI is moving into real world systems, like we just talked about. So there's a couple books that I just read. The Coming Wave frames AI as a foundational shift. It was written by the co-founder of a pioneering artificial intelligence company, DeepMind, current CEO of Microsoft AI. And I think it does a really nice job of framing AI as general purpose technology and understanding why buildings are next. Another book that I really recently enjoyed is called The Goal. It's actually about manufacturing, but it's a great way to think about optimization in any system. Like we just talked about the convergence of the asset classes. So that's a really good classic on like system optimization and bottlenecks, which we can learn from the past. In terms of podcasts, um, okay, I think the Invest Like the Best goes really deep on how trends play out in the real world. And then Jensen Huang from NVIDIA talks a lot about AI in the context of infrastructure, energy, physical systems, which is where I think things are heading. So what I'm really, really focused on is AI is shifting from something that analyzes chaos to something that actually controls environments. I think that's where we're going to see the biggest shifts. And that's also where it has the real economic impact.
It's very exciting. We are getting to live this.
Exactly. And people talk about it, right? Like how will this change jobs? Like we know it will change jobs. You and I don't look outside our window and see like locomotive engineers walking down the street, right? But
Right.
what we do know is there's many more jobs and new things that didn't exist before. And I think that's only coming. So it's a pretty exciting time for technology.
Well, Jennifer, thank you very much. I look forward to speaking to you further down the road.
Great.
Bye-bye. And thank you, listeners, for joining me on Sustainability Street. If you have any questions about this episode or suggestions for future episodes, please reach out to me at therese.fitzgerald@cpe-mhn.com. And don't forget to rate and review us on Spotify and Apple Podcasts. Bye for now.